Este.
Haideți să încercăm. Și sunetul merge.
Bine, eu am verificat cu prezentarea. Pot să...
Păi poate... Dacă în timpul ăsta ați apăsat butonul, înseamnă că merge.
Da,
Da, mulțumim. Doar închidem până
aici.
ce...
Eu o să o pornesc de acolo, doar.
I shall start in Romanian as we switch to English. Stimați colegi, membri ai Academiei, cercetători, reprezentanți ai ministerilor, reprezentanți ai mass media, avem deosebită onoare și plăcere, în calitate de oaspete, să-l salutăm pe domnul profesor Ashok Vaseashta, deci, vă rog, care a acceptat cu amabilitate să ne ofere o prelegere publică pe un subiect foarte și foarte actual, cel al apelor, cu care se confruntă omenirea întreagă, cu care se confruntă de asemenea și Republica Moldova. Cunoașteți foarte bine, cunoașteți și faptul că anul trecut, în raportul pe starea științei realizat de către Academia de Științe, a fost și un compartiment special dedicat problemei apelor în Republica Moldova, care a finalizat cu anumite recomandări. Îi salut de asemenea pe colegii noștri numeroși care sunt conectați prin intermediul platformei Zoom, de rând cu cei care vor asista la această prelegere, la discuțiile care vor urma, în urmărind transmisiunea live stream, datele despre care au fost afișate pe site-ul Academiei de Științe. Now let me radiological and nuclear. First of all, his activities deal with the problem of clean water. He is a director of the Institute of Clean Water in the United States of America. Professor Vaseashta has a long-term collaboration with Moldova. For 15 years, he permanently supports science and education in our country, being director of the NATO Advanced Study Institute, organized in June 2010, distinguished professor of the Institute of Electronic Engineering and Nanotechnologies. He published 3 books together with Moldovan scientists in the prestigious publisher Springer. He was also the supervisor of several PhD students in Moldova. And I am very proud to announce that section of the Exact and Engineering Sciences of Moldova nominated Professor Vaseashta as a candidate for election as a honorary member of our Academy of Sciences. And I hope next time we will introduce him as a member of our Academy. And before to give the floor to Professor Vaseashta, I would like to mention that we are honored by the presence of the State Secretary of the Ministry of Environment, Mr. Grigore Stratulat, and I give him the floor for a few words regarding the problem which we will discuss. Mr. Stratulat, you have the floor, and please switch on this microphone.
Bună ziua. I would like to speak Romanian, if you don't mind. Onorată asistență, stimați invitați, vreau în primul rând să vă mulțumesc pentru invitația de a participa la acest eveniment și mă simt foarte onorat să vin cu un mesaj de salut din partea Ministerului Mediului. Gestionarea eficientă a resurselor de apă este o prioritate pentru activitatea Guvernului Republicii Moldova și în special pentru Ministerul Mediului, a cărui intervenții strategice sunt îndreptate spre a îmbunătăți calitatea resurselor de apă. Resursele de apă fiind la nucleul dezvoltării intersectoriale, aduc și o provocare de a satisface necesitățile tuturor participanților fără a perturba echilibrul ecosistemului și în contextul schimbărilor climatice. Deci impactul schimbărilor climatice se resimte pe larg și mapamont, mai ales regional. S-a simțit foarte regional și în vara anului 2022, când am avut o secetă fără precedent în regiune și tocmai aceasta ne obligă să găsim și să identificăm soluții fezabile pentru utilizarea responsabilă a resurselor de apă, cât și pentru a proteja și conserva resursele de apă respective. Țara noastră depinde în mare parte de resursele de apă și volumele de apă formate în afara țării și de aceea suntem într-un constant dialog cu Ucraina și cu România prin intermediul colaborării pe platforma comisiilor bilaterale ca să asigurăm gestionarea durabilă a râului Prut și a fluviului Nistru. Mai avem și din poziția ca stat candidat al Uniunii Europene, obligații să avansăm pe aspectele legislative de transpunere a legislației europene, de reevaluare a directivelor europene și de a sincroniza legislația noastră la agenda europeană. În acest context, noi contăm foarte mult pe suportul mediului academic, care este un partener de încredere în acest proces. Sunt sigur că evenimentul de astăzi va rezulta într-un set de recomandări și concluzii care urmează a fi implementate ulterior. Vă mulțumesc pentru atenție și vă urez succes în continuare și rezultate pe măsura așteptărilor. Mulțumesc!
Vă mulțumim mult, domnule secretar de stat. Thank you, Mr. State Secretary. And now it's time to give the floor to Professor Ashok Vaseashta. Please.
Madam President, dear Minister of Environment from the Republic of Moldova, Professor Duca, Professor Sidorenko, dear colleagues, and I see several close friends online. So I want to acknowledge all of you for your kind presence. So with that, I'm going to talk to you about future of water, some of the challenges which we face, and some of the solution using exponential technologies. And some of these solutions are nature inspired and are bio-based. And as we continue to move into the presentation, the logic would be a little bit more clear as to why we want to use nature-based and bio-based solutions. It's actually quite a lengthy presentation. I'm going to give a small introduction of how we started with this project, what I plan to do, and after that, because there are lots of pictures, so I'm going to move little bit faster into the presentation. As you see, there are several books which we published together. The book on redox processes is currently in progress, and I hope that we finish this book in next couple of months or so. So with that, as you see this slide, this I had presented in a publication in 1989. At that time, we were looking at impact of pollution on environment, and we took a survey asking people to give us 10 topmost global challenges. And as you could see, water was one of them. So was environment, disease, education, democracy. And so far, these are still one of the top challenges. And after that, we did several more surveys looking at global, vertical, and horizontal priorities. I'll show you a little bit later that the plastic, although it's an opportunity, became a major challenge. So we'll see that as well. Following that, of course, there were 8 Millennium Development Goals, which were elaborated in 2000. In 2002, Johannesburg Declaration, in their Agenda 21, they elaborated 15 global challenges, which became Millennium Development Goals. Following that, of course, there were several more meetings. Now there are 17 Sustainable Development Goals, which are listed in this slide. I also collaborate with a futures group. We develop research methodologies. Although you see version 3.0, I think the current version is 5.0, and we look at different ways how we can solve global challenges going forward. And this is a Lifeboat Foundation group, and I provide the expertise on the Delphi survey methodology. Following that, we had a grant from NATO with Moldova, as you see on the left, for 5 initial partners. So we created International Clean Water Institute, which was funded by NATO through a Science for Peace project. And we developed several solutions at that point. And approximately in 2016, I created this International Clean Water Institute as a nonprofit organization providing providing guidance to our government, and they provide funding for this International Clean Water Institute. As you see, our objective is training, providing defense technology from security standpoint. So it's essentially a technology assessment sustainable model from different standpoint, but the eventual goal is safety, security, and sustainability. So that is a brief history into where we are into this project. So with that, here is a brief outline. We will talk about why water. I'll give you some data and statistics, and then we'll talk about future of water. Since the time is limited, I'm going to talk about some of these methods which we are looking into and make some recommendations which are listed here. And of course, I'll go through those recommendations as the time allows. And if the time should allow a little bit later, there are some platforms such as Advanced Science Convergence, such as Technology Accelerator Program. So I'll introduce them very briefly. I can make this presentation available to you because of the fact this is a very large sets of data. I wanted to give a global overview. So as mentioned, there's lots of data, but I'll be glad to provide a copy of this presentation if you should so choose. So let's talk about water. Okay, water is a very simple molecule of hydrogen and oxygen, tasteless, odorless, colorless. However, is the most exotic molecule designed in nature. And of course, it's by far the most peculiar molecule encountered by mankind. And the important part is if you talk to a physicist, if you talk to a chemist, if you talk to an engineer, all of them have a different definition of water. It has lots of useful characteristics. Of course, water is worshipped. I know my mother used to worship water. Water has fascinating and anomalous characteristics. And without that, life on Earth would not be possible. Density is anomaly. And that's the reason we have fish during wintertime, because of the fact they don't freeze, because of anomaly. Surface tension. Because of the surface tension, it forms drops, and that creates transport through the biomembranes. Boiling, freezing point, viscosity, density, refractive index, all of these are excellent characteristics of water. And because of its solvent characteristics, it dissolves a wide range of factors, and that's what keeps our body alive, because it takes all the toxins away from our body because of its solvent characteristics. So as I mentioned, it has lots and lots of wonderful characteristics. So if you look at this slide, our human body has tremendous amount of water, muscles, brain cells, blood, bones, and so forth. Water serves as a lubricant. Without that, I cannot even move my eyelid because of the fact it needs water for lubrication. Of course, water is the base of saliva. Water forms fluid that surrounds the joint, regulates body temperature. It detoxes our body and so forth. So obviously, we have a connection with water, which is important. And also, going forward, because of the fact water is most abundant in nature, as I will show you, water is also a gateway to the future. And that's the reason this is very important. It balances the economic prosperity and so forth. But nonetheless, from sustainability standpoint, I think it's very important. However, going forward, as you will see, safety, security, and sustainability, these are some of the major concerns. Water scarcity, lots of people, approximately, actually more than 2 billion people worldwide lack clean drinking water. And it has social economic aspects. Without toilets, girls typically would drop out of school because of the fact they don't want to go to a school where there are no toilet facility. 64% of the household rely on women to get families water. So obviously, as I mentioned, it has social economic aspect as well. Lots of people live in water-stressed area. And the interesting part is that over 2/3 of the population live in area where there is 80% of rainfall during 20% of the time. So either it's too dry or too wet because of those conditions. This slide shows a graph of scarcity versus stress as a function of time. It continues to increase. And this is something, as scientists, which we need to look into. And of course, globally, you could see that on a global basis, lots of countries have scarcity as well as stress. So I'm going to take you through some of the pictures. This is an area at the border of Uzbekistan and Kazakhstan, which we were monitoring since way back 1985 and so forth. So as you see, from 1985 to 1992 to 2000, the area, because of the fact there were lots of contaminants, it continued to degrade. And there are lots of people, literally thousands and thousands of people, those who became really sick because of the contamination in water. This is a project because Armenia was our partner. And because of that, I visited Kapan. And the reason this is important is because Kapan has lots of mines which were left abandoned after Armenia got independence. And those, they closed the lid on the mines, and the water continues to discharge into the agriculture and also the environment. So that area, it's very beautiful, but at the same time, water is severely contaminated. This is close to my home in West Virginia. As you could see, the water the contaminants are discharged without any type of a purification into the water. And the result of that is that large number of people in state of West Virginia has autism. And we wanted to make people aware of the impact of contaminants on autism. But of course, lots of people would not let us publish the result because of the fact there is no direct correlation between that. But nonetheless, this is something which we try to correlate, and there is now a correlation for that. Again, if you go to the internet, you will find lots and lots of pictures of this nature of contaminant globally across the globe. In terms of the disease, which all these contaminants bring, there are lots of statistics, and I'll read only a couple, that nearly 1 out of 5 deaths under age 5 worldwide is due to water-related disease. So many school years are lost, so much productivity is lost because of water contaminants. And now the COVID-19 in Boston, they observed COVID-19 virus in water. And of course, we cannot decontaminate, so it goes back into the water stream. So obviously, that's one of the concerns. And as we continue to progress, I'll mention a couple more contaminants such as microplastics and also pharmaceutical in water. So let's talk about plastic. As you see, all the trends out here continue to indicate that we continue to use more and more plastic. Worldwide, it continues to grow. But this is the main problem. All this plastic ends up in either in estuaries, rivers. People burn sometimes to generate energy. Of course, it then produces pollution. So this is something which we need to look into. This slide provides lots of data on the statistics of water. But nonetheless, as you see from this slide, the source, the majority of that plastic ends up in landfill. It gives the sources of plastic waste, discarded plastic waste. But what you see on the right is the amount of plastic that goes into the landfill. And once it goes into the landfill, it of course penetrates into the water tables. And then it converts into microplastics, nanoplastics, secondary microplastics. And of course, there is a continuous presence of that. And all of that ends up in our food supply chain. This is becoming one of the major issues. And this is something which we are looking into as to how to resolve that. We are also trying to see the toxicokinetic impact of the microplastic. There's not too much of data for 2 reasons. A, lots of research is not conducted. B, plastic industry has not encouraged toxicokinetics of plastic presence in water. So this is something which we need to look into. So the model which we had worked on for nanomaterials is the same model which we're applying for microplastics. This is something which we had published very recently. Microplastics, if released in water, it becomes hydrophobic and it tends to float at the surface and it attracts all types of bacteria, viruses. So not only it has health impact, but also it has security impact as well. So we are looking into that also. Interestingly enough, this microplastic emulates BPA, which is the same as the estrogen. So that means there is more plastic in water, there is more presence of estrogen causing abnormalities. And this was published sometime recently, where 30% of fish in California and Las Vegas had dual gender because of the presence of estrogen in water. And at that point, we introduced a term called drugs on tap because of not only microplastic, but also there are estrogen There are antibiotics, steroids, statins, acetaminophenes also in water. So again, lots of contaminants are there in water, so which we need to look into. So we then published, although this is a fairly crowded slide, but we were looking into pharmaceutical, microorganisms, metal oxides, volatile organic compounds, emerging contaminants versus their source, their concentration and health effect. That's what the slide on the back is. But on the left, what it shows is that 100% of people agree that clean water is a major problem, as you could also see from the data which I presented. So we looked into several different aspects, and some of the recommendations which I'm going to present, including water quality, and that's the reason we introduced something called Universal Water Quality Index, so that the water quality is consistent all throughout. And this was presented in one of the books which I showed in the initial slide. So let's now talk about the future of water, knowing the global issues which I just presented about the future of about the water. So in the future of water, I'm going to talk about some of the new and innovative ways to use, reuse, recycle water. I'll also talk about cyber-physical systems. This is a subject which I teach at several different universities, and this is essentially an Internet of Things-based monitoring system. And this is something which we also had produced along in our NATO project. So essentially using IoTs, Internet of Devices, based contaminants, we could regulate water. I'll talk about atmospheric water harvesting and transboundary water management and use of biofriendly compounds for water filtration membranes. But as mentioned, since time is limited, some of the recommendations which are listed, I'll provide those recommendations later. Okay, so let's talk about the water source. As you know, the Earth has tremendous amount of water, but the usable water, which we can use as a fresh water source, is only 2.5% or less actually, out of which groundwater is 30.1% and polarized is close to about 68, 69%, which we cannot use. So out of the groundwater, there are three primary sources: lakes, rivers, and atmosphere. So as you see, atmosphere is 0.037%. That's the largest, second largest reservoir of water. And that's the reason atmospheric water harvesting has become very important, because that serves as the second largest source of water. So I'll talk about that a little bit later as we go into the presentation. In terms of use, there are three primary uses: domestic water, industry, and agriculture. Agriculture by far takes the largest amount of water. For this presentation, I'm going to only talk about for the domestic use or the potable water, although same principles apply for agriculture as well as industry. So there are lots of regulation for the potable water, for safe drinking water, for aircraft and all types of applications. But as mentioned, most of my discussion will pertain to potable water, although we could use pretty much same principles for the agriculture as an industry. So the first thing which we do is we try to use nanomaterials for different types of application in terms of sensing and detection, in terms of removal of contaminants, in terms of providing support for the water. And the reason for that is that because of the fact nanomaterials have dimensions which are comparable with the fundamental physical quantities, we can select a material of our choosing, we can design a material of our choosing, and it gives us the leverage, something called material by design. That means specification based on materials versus material based on specification. So this is the advantage which nanomaterials provide. And I'll take you through some of the devices which we made, again, fairly quickly, just to show an example. But this slide simply shows as the dimensions reduce, the surface area increases. And what that means is, as the surface area increases, so does the activation energy. As you could see by the equation, energy is obviously, it's proportional to surface area. So more surface area you have, there is more surface activation. That means it becomes more sensitive. In addition, we could functionalize with a specific receptor on the surface. And having that, we can pick and choose any type of a contaminant. So I can pick chemicals, I can pick biological molecules, anything which you design, we can then make specific receptors. So I'm going to take you through some of the devices which we made. These are some carbon nanotube-based sensors, chem biosensors, which we made. You could take different types of analytes, bring in contact, and of course, it changes their characteristics, may it be in terms of conductance, may it be in terms of their frequency dependence, but you could detect different types of contaminants by carbon nanotubes. Also, we made ChemFETs, chemical field effect transistors, and also put them onto these probes called electronic tongue for sensing and detection of different types of contaminants in water. We also produced nanoporous silicon-based sensors. And the interesting part is that if you bring an analyte in contact, if you take the resonance spectrum with or without those analyte, the difference in those characteristics is a characteristics of specific contaminant that comes in contact. As a matter of fact, on the left bottom side, you see Homeland Security made devices, and these devices were used in subway metro station to find if somebody is dispersing any types of chemical contaminants. We also made electrochemical sensor. These are simply based on graphite pencil electrode. You bring analyte in contact, and then, of course, it will give hybridization signal based on analyte which has brought in contact. We also made surface plasmon resonance because of the fact if the refractive index depends on what's added into those analytes. So using a light source and CCD array, we could detect E. coli, we could detect prion, and so forth. So these experiments were also done on different types of contaminants. We could also make electronic nose system. These were pads which had different concentration of nanomaterials based on carbon. They were embedded into the system. So not only they could sense different types of radiation, but also different types of gases. You could put them with a PDA and detect different types of contaminant. We also made something called nanotagants to track, trace, and authenticate different types of contaminant. And one interesting aspect was introduction of transition metal elements. And the interesting part is that if you add transition metal, the reflected frequency shifts to a higher order. That means if you shift 500, you might get 550 back. And that characteristics was very useful for detecting different types of chemical and biological agents. So this is an overview of the fact that we made different types of sensors and detectors. Some of them are used for real-time chemical, biological monitoring of contaminants in water, but also we could use them with templates, which I'm going to show you in the following slide, to capture those contaminants and also pharmaceutical. So this technique, which I have shown in this slide, is called electrospinning. And I'm sure especially students know this technique very well. This is by far one of the simplest, more versatile technique of making different types of nanofiber. All you have to do is put a little bit of polymer in a syringe, apply electric field, and then comes out the fibers. So we could embed these fibers with different types of materials, as is shown in this slide. I'll go back to the previous slide in a little bit. So by adding carbon nanotube, by adding oxides, by adding different types of material, we could make different nanofibers for different application. So what you see in this slide is simply a electrospinning apparatus on the left, and on the other side, the B is a having a shell and a core. That means you have a fiber within a fiber. So you could make different configurations. But the interesting part was we could add different types of elements or different types of oxide to make different types of fiber. The table which you see on the screen, it took 2 years to generate the table because of the fact we tried to find different polymers and different additives and make different types of nanofiber. This is an interesting experiment which a student, now she's postdoc, she does in Turkey. Unfortunately, I know that, and my prayers to all those folks, those who are suffering in Turkey. She has done these wonderful experiments of adding T nanoparticles by adding ginseng, by adding saw palmetto, turmeric into polymers, and make these polymers for pharmaceutical types of application, because of the fact most of them have characteristics which are obviously have pharmaceutical types of application. So this is an interesting experiment which is in progress, and we continue to work on it, adding different types of herbs and spices into nanofiber and make application. And these are also good for green synthesis. So based on all the publication which we published on nanofibers, what you see on the screen is Chinese. They had produced commercial apparatus, and they were nice to acknowledge work which we had done because they had put that in reference. So now these are commercially made, commercially available electrospinning apparatus by which you could make lots of different applications. Some of them being membranes, which are embedded with nanomaterial to capture pharmaceutical and also for microplastics. And I'll show you a couple examples a little bit later. But the interesting part is that these membranes, which are made by electrospinning fiber, they do not have the mechanical rigidity. So what we started to work on now is to integrate that with 3D printing. So the 3D printing provides mechanical support, and then you put electrospinning. So a combination of these two provide membranes for different types of application. How much time? Okay. So for different types of applications. So this is a new process which we are working on, a synergistic combination of 3D printing and electrospinning membranes. What you see on the screen is different methodologies of 3D printing, going from fused deposition to stereolithography, digital light processing, polyjet photopolymer. As long as you have a digital file made, you can take a picture and produce something, or using AutoCAD, you can design something, and by 3D printing, you could reproduce that. So there are lots and lots of possibilities which are possible using a combination of 3D printing and also electrospinning. This method which we introduced some time ago, and this is essentially a combination of electrospinning and 3D printing together. As you see, we have a a syringe with a polymer. And of course, using an electrode, we can direct deposition at a specific location. So this is an integration of 3D printing and electrospinning together. And as long as I can put different chemicals into the polymer solution, we can make these structures for almost any application which you could think of. So this is a scaffold which was made using the method which I had shown in the previous slide. You do a 3D printing and then transfer over to electrospinning. You do 3D printing and you can continue to prepare layer by layer. And some of these structures are shown in this particular slide. So this gives us lots of possibility of making membranes for filtration, scaffold, multiple applications. As mentioned, the applications are almost unlimited. We could make biomarkers detection using electrospun membranes. So these are US Army wants to take this structure and provide the soldier so that whenever there is a drop in blood sugar level, they should be able to detect that. And of course, it has mechanical rigidity and also functionality. This is an interesting experiment again in Turkey, which we are conducting. And this is detection of antibiotics from the wastewater using cryogel. And these are the ones which can remove antibiotics, statins, estrogen from water. So this experiment is currently in progress. And based on the work which we had done, US Army had approached us to provide, the examples are on the left, to provide wearable kidneys for water desalination, water purification, wearable anti-dehydration system, gas masks, and so forth. So as you could see, applications are unlimited. Only thing which we are short of is manpower to produce all these applications. Extension of 3D printing goes into dental product, IVR, architecture, prosthetic. Architecture aspect is something which I'm currently working in Brasov, University of Brasov, making energy harvesting devices and also for structural health monitoring, prosthetic movie props, reconstruction fossil, replicating ancient artifact and so forth. And what you see also on the screen, a researcher using 3D printing has prepared a heart, and this is in University in Tel Aviv. My alma mater, Virginia Tech, they work on prosthetic, and they, I don't have a picture for that, but yeah, they make different types of prosthetic for people, those who have returned from battlefield. They may be missing limb, so we can produce those limbs for those types of folks. So again, there are tremendous amount of application for that. So let me very briefly talk about the atmospheric water harvesting. As I showed you before, the atmosphere serves as the second largest reservoir. So it has application in atmospheric water harvesting, fog water collection and dewater collection. That has been going on for a very long time. But now using 3D printing and also with electrospinning, I'll show you some of the applications which are currently in progress. These are some of the experiments which are in progress at different locations. AquaScience by far is the largest source of atmospheric water harvesting devices they make using a metal organic framework, and they can capture water, and by heating and cooling, they can extract water. But the application which I want to show, which is the nature-inspired solution, leaves have a very specific shape and also surface adhesion. And that's the reason they can capture water and then, of course, funnel it to a specific location. Also, a cactus has a very specific tip shape. So what we have done is we have taken those structures using 3D printing and also electrospinning. We can create those shapes and make large devices which can capture water. So we have produced those types of devices. And of course, the large shapes one can produce based on those experiments and can capture lots of water. And one of the largest user of this is United Arab Emirates. As you could see from the building, they are not only using atmospheric water harvesting, but also hydroponic, for example, for production of different types of plants, etc. So we've talked to folks in UAE, and they want to use this technology, which is based on electrospinning and 3D printing. So we look at the nature, we try to reproduce that by some of the technologies which are currently in use and see if they want to adopt the technology for large-scale production of these types of structure for buildings completely in the middle of desert where there is no infrastructure, because they can capture tremendous amount of water from the atmosphere. So this experiment is in progress. And of course, we had proposed to UAE to see if we can move forward with this project. The next topic which I want to talk about are the international basins. That's the second, another large source of water. There is lots of water underground, but because of the fact these basins are shared, there is always a transnational conflict, which I think we need to resolve. As I've stated, more than 40% of world's population live within the transboundary basins, and the number of countries that share is about 145. But nonetheless, because of the transboundary conflicts, this becomes a diplomatic solution. And of course, countries, they can work. Some of the examples of the conflict regions I've listed, such as Jordan, Syria, Nile, Ethiopia, Sudan, and Egypt, India and Pakistan, that war has been going on for a very long period of time because of the transboundary region. And Euphrates, Turkey, Syria, and Iraq, they also have a problem. But nonetheless, this is another source of water which one can tap into. The other application is use, reuse, and recycle. That would be a future source of water. We need to, again, some of the applications which I've listed, the percentage of water which is used for shower, washers, toilets, dishwasher, and so forth. But nonetheless, we need to find ways to recycle that water going forward. Again, limited consumption, reuse and recycling, elimination of losses, and pollution prevention. This is where Internet of Things devices perhaps can help. And the table which I have shown at the bottom, these are some of the actions which we had proposed to the government to see if we can implement those actions to help us recycle water. Something which we have also introduced is region-specific contaminants. What this simply means is contaminants in a certain region may not be the same as a contaminant in a different region. The same technology is used globally for decontamination, and that does not make sense. That's not efficient. If I do not have arsenic in this region, I should not be detecting and isolating. So this is something which we need to do that would be far more efficient to exercise those types of strategies. I'm going to take it to 2 or 3 slides on the Internet of Devices, because of the fact we live in such a highly connected world. That's the reason I teach this subject called cyber-physical systems, which is a multidisciplinary field. It essentially integrates the dynamics of physical processes with the software. But the more important part is that as long as I have a physical process, I have a application space, and there's a feedback, we can make devices which can sense and control. And this is what we use for detection of water, let's say leakage, so that we can prevent those types of leakages. So because of its application, not only in water, but also in infrastructure, this subject has become very important at universities, and lots of professors, they have started to teach this subject. Also, as you see from this slide, the Internet of Things devices, they are exponentially increasing. So this has become a core topic of teaching. As a matter of fact, we have also introduced something called Internet of Behavior with Internet of Things, and use that as a combined subject, which is currently in use. It has lots of application, EU, and of course, National Science Foundation, because of its application in economic opportunity, prosperity and growth, safety and security, health and wellness, improved quality of life. They have increased funding for this subject. So that's the reason there is a lot more interest as it relates to environment. So we are introducing this subject. This is a slide from Labelium, systems software type of a structure, where they show that they have embedded this IoTs in almost all aspects of our life, so that we have a better management of our resources. As I mentioned, region-specific contamination strategy. This is essentially stating that, as I mentioned, not all contaminants are at all locations. So using a strategy of region-specific contamination detection and remediation, lots of companies are actually using this, commercial adaptation being Drinkwell, Oneco. So, and of course, this makes sense because of the fact you don't have to remove something which does not exist in the environment at a specific location. All right, 2 slides on the bio-based plastic. This slide simply shows that the production of bioplastics is increasing as a function of time. And here's the reason for it. As much as we use plastic, you know that the microplastics presence, as I showed before, is increasing. So realizing that we have to live with plastic, but at the same time, we have to make bio-based plastic. Lots of industries have shifted their focus from fossil-based plastic to bio-based plastic. So that's the production. And so what we are trying to do is, based on that, we started using lignin, for example, cellulose, and see if we can shift our focus from conventional plastics to bioplastics or bio-based plastics, and shift and continue to, so in terms of electrospinning, for example, so rather than polymer, we have started using bioplastic to see if we could produce membranes and devices based on those. So this is at the very initial stage. Although I'm not a polymer chemist, those who are polymer chemists, perhaps can do they can add more to it. But nonetheless, there is a global trend of shifting plastics to bio-based plastics. And industry, they have already noticed that. And that's the reason globally, there is a large amount of shift in the production, as you see from this slide. Okay. I see the bell. So I'm just going to spend 4 or 5 minutes to talk about some of the methods in terms of technology convergence. We have a technology convergence accelerator program where we bring people, those who have technology, and industries, those who want to use their technology. And that way, knowing the society, knowing the science and technology, future drivers, we can then shift the outcome. So we have a program on technology convergence. We also have something called Materials Genome Project, where from discovery to market, we can reduce simply by using, by fostering collaboration, by creating a robust digital data information infrastructure, and also cyber facilitated toolbox. So this is a project which is funded by National Science Foundation on Materials Genome Project. So this is a community-based knowledge infrastructure to accelerate discovery and innovation. As I mentioned, that we also do decision support tools. One of the methods which we used is called Advanced Sciences Convergence. And using that, using different types of surveys, we could propose solutions not only to government, but also to commercial customers. And of course, we use different types of tools, decision support tools. Some of them are shown in this slide, such as TechForm, Adams, and Nests. And lastly, we use different types of algorithmic tools, such as artificial intelligence, machine learning, data analytics, virtual reality, etc., to see if we could optimize and, of course, enhance the productivity. So these are commercially available tools which we can integrate into our projects to increase their productivity. What this slide simply shows is a human brain. We may not be able to accomplish using artificial intelligence all of that, but obviously the goal is to see how we could maximize based on our human evolution into nexus of technological platform using all of this artificial intelligence. Transdisciplinarity, CIRIT is a French-based organization on transdisciplinarity. I was fortunate enough to be a member of that. And in a way we do that. We take this technology, transform that to society. So we are using transdisciplinarity in catalyzing innovation into engineering and research. So that's something which I do on the side. I'm going to pass this slide. But so here are some of the final recommendations. What you see on the screen are some of the companies: EcolBlue, Atlantis, EUL Water, Aquascience. They are already using this technology, which I had mentioned, into commercial production. So although it seems out of the blue or emerging technology, but most of these commercialization has already started. And of course, we can tap into that. And with that, these are, I think, the take-home message from the presentation, that water is an exclusive resource that we need to carefully manage, use, and reuse. Implement universal water quality index. That way, all of us will have same quality of water. Research to mitigate emerging contaminants in water. Persistent monitoring of contaminants in water. Reduction of micro nanoplastics. Reduction of returned pharmaceuticals. Advanced technology to ensure water safety. Alternate ways to harvest water, such as atmospheric water harvesting. Enhance aquifer protection, and of course, using diplomacy so that all of us can use water. Water management strategy, catchment basins, watersheds, etc. Secure network to ensure safety of critical infrastructure, and use of AI, VR, and digital management, digital learning, etc. So with that, I close the presentation. Of course, this requires a huge collaboration, and collaboration with Moldova obviously has been instrumental to all what I presented here. Thank you.
Thank you very much, Professor Vaseashta. Let us continue in follow way. First of all, questions, if any, and after that, opinions and comments. Are there some questions, please? Professor Tsiulianu, please.
Dear Professor, thank you very much for so interesting lecture. I would like to ask you something about several words about this known method of water cleaning via ultraviolet treatment. What do you think about the reliability of this method, as well as economic opportunity, that is financial opportunity, and maybe several words about how large is used this method in the United States? Thank you. The question all about the method of water cleaning via ultraviolet treatment.
Yes.
If you several words about reliability, financial opportunity, and in the United States, how large it is.
Okay. I'm sorry, I had to come closer to hear the question. My apologies. Use of ultraviolet, that has been in use for a very long period of time. And this is still a viable technology, which is very widely used for commercial application of the killing bacteria, for example, or isolating bacteria using UV technology. So all the technologies which are already in use, what I have proposed does not exclude those. These are in addition. And here's the reason for it. What I have presented are some of the new contaminants. The typical techniques which reduce contaminants are simply for arsenic or different types of metal, chlorine, etc. But they do not isolate pharmaceutical, they do not isolate microplastics, etc. So the method using nanomaterials, which I have proposed, are essentially designed for emerging contaminants. And these are used in addition to already existing methods. So UV has been in use for a long period of time. So I hope I've answered your question, because as I mentioned, in addition to UV, nanomaterial-based methods which are proposed are for those types of contaminants, such as the microplastics and the pharmaceuticals, etc. But that's a very viable method. It's widely used, and it's used in parallel to the existing methods.
Thank you.
You're welcome.
Thank you very much. More questions, please?
A question, if it is possible.
Please.
Recently, the ice with density higher than the water density was discovered. What is the probability that such ice can exist in any specific conditions in the land and sea? Thank you.
Domnul membru corespondent Geru, vă rugăm de aici se aude cam rău, vă rugăm să formulați întrebarea în limba română și cineva de aici o să traducă.
Poftim.
O să fie mai bine, da, vă rugăm.
Nu de mult s-a descoperit o formă nouă a gheței. Gheața aceasta are densitatea mai mare decât densitatea apei, spre deosebire de gheața obișnuită. Întrebarea: care este posibilitatea ca acest tip de gheață să existe în anumite condiții pe pământ sau în mare, la Polul Nord? Asta e întrebarea.
Professor Vaseashta, the question of Professor Gero was the following. Recently, it was discovered ice which has density more than density of the liquid water. And the question is, does exist the probability to discover such form of ice on the Earth? Or maybe it is just the theoretical invention? It's first of all, it's a great question. In terms of the usable water, the statistics which I had presented, because since we are running short of water, we are looking into different ways where water can harvest or water can be harvested from. So if there is some additional resources which are discovered, I'm sure one can use them in a way that can be converted into useful water. But our focus has been on the availability of those resources which are readily available without actually using any additional technology. As mentioned, the atmospheric water has been in use actually for centuries. But what we have done is use exponential technologies such as electrospinning and 3D printing, which I have mentioned, to see if we can accelerate its capture. Because we are running short of water so quickly that we need to find ways to not only capture, but also water management in terms of use, recycle. So if there is a theoretical or newly discovered ways, I'm sure there will be ways in future, but our effort is on the two aspects. On the reuse, reuse, and recycle by using nanomaterial, see how we can remove the contaminants and also recycle those water, and also on atmospheric water harvesting. So these are our current focus. But nonetheless, I appreciate the question.
Yes, thank you very much. Really, the vital is to resolve the problem of just clean water.
Exactly.
Because, yes, nowadays it is the most important to survive, just to survive the life on the earth. Yes.
Something which I have not mentioned in this presentation, and although it was initial aspect of our project together, which we had with the Academy of Sciences, which NATO funded, is the water security. And as I mentioned, although I did not include that part, but that was one of the major concerns, where people would intentionally want to contaminate water. So some of these sensors and detectors, which I had mentioned, had a specific focus on finding those contaminants, chemical and biological agents, how we can quickly detect and remove those contaminants, because that was initial part of our proposal. Today, I wanted to focus on safety and sustainability, but nonetheless, as a critical infrastructure focus on water security, all of these topics which I've mentioned have a use in the water security as well. And this is part which, as mentioned, with my association with University in Brasov, where we look at critical infrastructure. We also have a proposal on the detection of these contaminants in water aspect, which we are looking into as well.
Water is very interesting substance, because now exist about 56 anomaly property of water. Professor, a member correspondent of Academy of Science, Gero, 5 or 6 years ago, present on new anomaly property of water. And every time discover, well, this is what is very interesting.
Right.
Thank you. As far as I understand, we switch on to comments, and I would like to ask Professor Academician Duca to give the first comment, and Professor Vaseashta, if you wish, you can take place here.
I would say some compliments and some comments. And some words for okay. I want to say again, I want to say some compliment, some comment, and some proposal for Minister Stratomat. First of all, I want to say, my dear friend, big friend, Professor Ashok Vaseashta, thank you so much for this impressive academic and excellent lecture, which is great for science and practice. You fully deserve to be an honorary member of our academy. Second, I would like to thank Academy of Science of Moldova to organize this meeting, this lecture. The water problem is very important for the Republic of Moldova, and we are very interested in taking over the experience from United States in order to contribute to the development of the economy and the environment. Today, everyone is concerned about climate change, as say Minister Stratulat, which has a great impact on the quantity and quality of water at the local, regional, and global level. Dear my friend, Ashok, you have established an excellent long-term collaboration with researchers from Moldova, working, for example, with in the Institute of Chemistry and the Institute of Nanotechnology. Among these, you received an award from the Chemical Society of Moldova, Ecological Chemistry Medal. You were a member of the scientific and organizing committees of the series of the International Ecological Chemistry conferences in the period of 2014-2022. You were the director of several joint projects and more than 10 joint research articles with Moldavian chemists you publish. I would like to especially mention here a good collaboration of the Professor Vaseashta with our Physical and Inorganic Chemistry Research Center, our Physical Quantum Chemistry Laboratory, chief of our laboratory, Dr. Yolanta, is present in this meeting. Our laboratory from Institute of Chemistry of Ecological Chemistry, academician Tudor Lupascu. Our Department of State University Ecological Industrial Chemistry, Dean, and is Dr. Verica Glad. You was marked an appearance of 3 large textbooks presented together in your lecture. In addition, joint publications have also appeared in the International Journal of Climate Change. Bioremediation, and other international journals with a high impact factor. Now we are in preparation of a joint research project with you and with Moldavian chemists. Dear Professor Vaseashta, congratulations for being promoted to our exact sciences. Chief is a member of Academy of Sciences, Svetlana Kojukaru, our section, as an honorary member of our academy. Now we include you like researcher in our national project mechanism of electron transfer and redox process with the vital important for environment and technology. And now I want to say in Romanian, because my friend now this idea what I want to say. Vorbesc acum, sigur, că în română, pentru toată lumea care stă aici și pentru domnul secretar de stat Strutulat. Dragi colegi, vreau să mă folosesc de această lecție și de prezența secretarului de stat, domnul Strutulat, și să spun ceva. Anul trecut, după audierile proiectelor naționale, Prezidiul Academiei de Științe, în prezența, sau mai bine zis, a doamnei vicepreședinte, doamnei membru corespondent Svetlana Coșucaru, a însărcinat câteva grupe din institutele de cercetare și universități care au proiecte naționale să prezinte câte un program de stat important pentru dezvoltarea țării. Nu știu cât a fost, 3, 4, 5, nu mai multe, din toate 200 și ceva de proiecte. Eu am fost numit de prezidium conducătorul proiectului legat de aprovizionare cu apă. Au lucrat 10 experți, 6 din Moldova, din proiectele moldovenești, 3 din Italia, Germania și din Statele Unite a fost domnul Vaseashta. Și a lucrat încă și a activat și directorul Institutului Aquaproiect, domnul Valeriu Cătrânescu. Am prezentat aceste propuneri la președinție, Parlament și Guvern. Toate instituțiile de stat de vârf au îndreptat acest proiect unde? La Ministerul Mediului. Au greșit. Ministerul Mediului nu avea, pentru că acest proiect era un proiect de infrastructură. Trebuia să fie îndreptat domnului, cum îi spune?
Andrei.
Da, Andrei Spână.
Spână, da.
Și Ministerul a răspuns că nu este treaba noastră, nu este un proiect de protecție a mediului. În ce consta acest proiect, domnul Strutulat? Eu încă o minută, doamna vicepreședinte. Acest proiect consta în aprovizionarea, deci organizată cu apă în Republica Moldova, care ar putea să aducă multe investiții. Noi avem 2 râuri, Nistru și Prut. Debitul râului Nistru e cam de vreo cu multe mai mare decât debitul Prutului. Așa, noi am vrut și propuneam ca să organizăm un sistem de aprovizionare cu apă la nord, în centru și la sud. La sud din Dunăre. Și eu cred că acesta este un proiect național care a rezolvat foarte multe probleme economice. Și vreau să vă rog pe dumneavoastră, ca secretar de stat, să reveniți la propunerile Academiei de Științe. Eu vă mulțumesc. Thank you so much.
Thank you, academician Duca. Domnul Strutulat, chiar vreau să vă ofer cuvântul. Nu știam că va face această referință domnul academician. Vă rog frumos un mic comentariu.
And she actually put me in a very, I would say, difficult situation because I don't know what initiative that you have forward to the government and parliament. We always have an excuse. I was recently appointed only on January 25th, so what I can do now is that I will take it into consideration and I will make additional research on that subject. In terms of your presentation, thanks a lot. I have a very small, not a comment, maybe a question. In terms of sustainable water use for our households, because it's a matter that is always discussed in our society, especially with the tariffs that the households are paying for water. Is there a research that would describe the correlation between the water tariff, water consumption, application of new technologies to reduce water use in households? Thank you.
Mr. President Tichineanu is coming after a meeting at government. Please, I invited him.
He was in a meeting at the government. So first of all, let me welcome Professor Vaseashta to the Academy of Sciences of Moldova. And of course to welcome all of you and the State Secretary, Mr. Stratolat. I would like to know that we, for several years, used to invite specialists of top level at from the world, and Professor Vaseashta is one of them. And we just recently at the General Assembly, the meeting of the section of exact sciences and engineering, discussed the issue of awarding you the honorary title of the honorary member of the Academy of Sciences of Moldova. This the decision was positive, but this is just the first step. We should at the General Assembly discuss this, but I have no doubt that everything will be okay. You, of course, have been in touch for a long time with the scientific community of Moldova, especially with the Institute of Nanotechnology and Electronic Engineering, also with other institutes, Institute of Chemistry, and we are grateful for your participation in joint projects, for your assistance. We have many bridges of collaboration with the United States, and the bridge that you created in collaboration with our researchers is one of the most reliable. And well, probably this is because it's related to security, is related to the quality of water, and actually the water is a source of life. Life appeared in the water, and without water, life cannot actually, most part of our body is actually water. Yes. Ladies and gentlemen, I consider that today it's a great day. It's like big, how to say, celebration, because the lecture that have been presented, I actually had no possibility to attend, but I have read the abstract of the lecture, and I actually attended several lectures that you presented previously. Thank you, by the way, that you participated in many conferences organized by our researchers, and also you presented lecture at the International Conference on Nanotechnologies and Biomedical Engineering. And well, this year, this conference will take place from September 20th to September 23rd. And of course, you will be very welcome to participate in this conference as well. I would like to thank all our researchers that organized this public lecture and actually attended this public lecture. I see that many of them are online. It's very an impressive here list. So I consider that you are a member of our scientific community, and therefore we will, of course, the next meeting of the Assembly discuss the issue of awarding you the honorary member title of the Academy, and you will be then a member of our community, of our academicians. And of course, we hope that the ties, the collaboration that have been established over the last 15 years or so will continue. So thank you so much. And so we look forward. So, yeah, please add.
Okay, but before closing, I would like to ask academician Sidorenko to say a few words, and after that we will finish.
Okay.
After
Yeah. In case there was a decision to stop, then
dear Mr. President, dear State Secretary, dear friend Professor Vaseashta, dear members of Academy of Sciences and colleagues, I would like to attract your attention to the one of the most important key question of today's session. Professor Vaseashta, no doubt, is a worldwide known expert, and this is clear, visible from his lecture, from discussion, from his participation in a lot of conferences in Moldova. But I would like to attract your attention to the key word what just said President Academy of Sciences, academician Tiginian. Professor Vaseashta belongs already to Moldovan Scientific Society. It is a very important issue. Now we would like to formalize this thus existing state. Professor Vaseashta already 15 years permanent participate in our scientific life, not only by conferences with excellent lectures, but initiating and participating in several projects, NATO projects with Institute of Physics, NATO project with our institute, organizing together with me 2 big NATO conferences, Advanced Workshop, and in 2010, Advanced Science Institute NATO. That time we make acquaintance, and I recognize that it is an excellent scientist. By the way, he has 2 educations, and he graduated from the most famous Indian Institute of Technology. I would like to say that the best of the best students can enter this Indian Institute of Technology, 40 persons per place. The very big conference. He defended the PhD thesis, and then he continued his education in the United States, and he defended doctor habilitation thesis. That's why he has all steps of increasing his scientific level. And here in Moldova, in our institute, he is distinguished professor, member of our institute since 2012. That's why the key word is, I repeat that it was said that Professor Vaseashta does belong to our scientific society. He supported during these years not only scientific life but also education. I see on the screen several his PhD students. Under his supervision, several Moldovan young people prepared and successfully defended their thesis. That's why he plays a very important role in development of science and education in our country, and I believe that we will watch in the nearest future for by election him as a member of Academy of Science of Moldova. Thank you.
Yeah, thank you. Thank you very much. And there was a question, and you wanted to give an answer. So please.
Thank you for the wonderful question which you had asked. In fact, as part of water management, this is already being considered in terms of water management at home, using Internet of Things devices so that we can monitor the use of water. Also, in a couple of proposals and also in publication, we have proposed usage of water, because for kitchen, we use different quality of water than for the toilet, for example. So to conserve the potable water, we could perhaps use different sources of water. And I think that would be part of use, reuse, and recycle philosophy that will reduce the consumption of water so that more people have quality water, which is the potable water. So it's part of management strategy, which is already looked into. And also we made several recommendations as to how to have good quality of water, which we use for ourselves. And of course, for watering plants, for example, or for toilet, we use different quality of water. So it's all part of water management, and using IoT, manage and control the use of water and reduce the leakage. 30% of water in homes is goes into leakage. So if we can stop that leakage, that means we will have 30% more water. So we are looking into that aspect also. Thank you. That was a very good question.
Thank you so much. You see, there are a lot of energy actually around us, and there is at the same time a shortage of energy. You know, from the sun we get a lot of energy. In 1 hour, the Earth gets energy more than the humanity uses during 1 year. And the same with water. There is a lot of water on our planet, but at the same time, there is shortage of drinking water. Yes, these are the features of our century. And therefore, of course, all this, the solution can be identified only by researchers. And thank you that you visit us, and I am sure that you have excellent ideas how to identify solutions for to assist the civilization to survive on our small but beautiful planet. So any other questions, please? Questions, or maybe somebody in any language, I mean Romanian.
I have a question, if it's possible.
Oh, perfect. Go ahead.
Yeah. So good afternoon. First of all, can I speak or no?
Yeah, Professor Boris Boyancian, go ahead. You can speak.
Yeah.
Please.
Thank you very much. Thank you very much. First of all, I would like to thank very much Professor Ashok Vaseashta for a very thoughtful, very impressive, and very inspiring presentation. Really, the issue of water is crucial. And as you have mentioned in the beginning of your presentation, so global warming, water deficiencies are two of the main questions. In our understanding here, very important is the role of soil, because soil is on the interface between hydrosphere, biosphere, atmosphere, and lithosphere. So this is a special issue. It would be nice to have the possibility to discuss more about this. But my question now is, and the previous, which our colleagues before asked, so what is limited resources, but at the same time, it's not rationally used. What is your opinion about water credits? Do you think that they can help in some extent to use more rationally water? Because it's not normal when potable water is used for technical purposes. So what is your opinion about water credits? It's like, for example, we have carbon credits, which are very important for carbon sequestration in agriculture.
Okay. Let me see if I understood the question right. Your question is about limited consumption or the water ration. Did I hear that correct?
Yeah.
Okay. In future, of course, our human body requires a certain quantity of water, obviously for daily functioning in terms of food consumption, in terms of personal hygiene, etc. So that I foresee may not change as well, but as I discussed with the minister, that by managing water appropriately, meaning thereby water consumption, let's say for portable water, for kitchen, for drinking, if we use a certain quality of water for that and use that recycled water for other applications, such as for toilet, etc. I think for personal consumption, we could manage those resources well. I foresee going forward within home, we will have filtration types of system built into our homes, which will not only manage, but also internally channel water from one application to the other. So we'll be using same quantity of water, but they will be managed to a point that there would be mechanism that from one consumption, recycled water is used for different source. So essentially, we are using less water because we are recycling more. So reuse and recycle would enhance. As I mentioned, we do need a certain quantity of water for survival. That may not change, but our strategy of using, reusing, and recycle will change. This is what I foresee, but of course, time would tell. And I also foresee that some of us would use atmospheric water harvesting, even at home, once those types of application become available to us.
Thank you very much.
Yeah, thank you. Are there any other questions? Mai sunt întrebări? Domnul academician Duca, please.
If you understand, you accept the use of the underground water for agriculture?
Okay. For agriculture, underground use of water and some of the recycled water, which has, rather than going into waste, we could perhaps recycle that water for the agriculture types of application. So essentially, water management strategy within home using Internet of Things types of devices, I foresee that would be one of the big technology which will be used at home so that we have water for all application, including for agriculture within the homes.
Yeah, thank you. I think that there are so many aspects of this issue, and we will wait for you in some time to come again and to go deeper into all these issues related to the use of water. Stimați colegi, mai sunt întrebări în spațiu virtual? Știți, avem multe probleme, dar eu cred, cum de obicei spune domnul Câncian Bologa, noi vom reuși pe lumea asta, deoarece în ajutor ne vine domnul profesor Vaseashta. So, thank you so much. And I have here, you see, an agenda. It's agenda. It's a special agenda. All plans that you will put down here will be realized. And here also you have a calendar, and so all the best to you.
Thank you.
And so you always will be welcome to the Republic of Moldova. As academician Sidorenko said, you are a member of our community. So we will prepare a special document. Member.
Do you mind if I take a picture on my cell phone? Can I take a picture with you on my so I'll give it to
You would like, okay, once again, we repeat.
yes.
So thank you so much. And you look then to yes, and this is
Thank you.
Perfect. Perfect. Și mă aduc mulțumiri și domnului secretar de stat. Domn secretar, veniți mai des la Academia de Științe, că noi chiar discutăm aici probleme foarte și foarte importante și vreau să vă spun că am avut prelegeri și a unor personalități mari de peste hotare, experți de talie internațională. Da, și vreau să, în general, câteodată vin și miniștri și da, nu totdeauna. Da, și iată, domnul profesor Boiencean iarăși a avut prelegeri excelente și mai mulți cercetători și de ai noștri și de peste hotare și trebuie să avem o conlucrare mai bună, mai eficientă, fiindcă scopul este comun. Să ajutăm țara să se dezvolte. Vă mulțumim. Mulțumim. Stimați colegi, vă mulțumim. O zi